everyone, my name is Mrs. Anthony and I teach 5th grade at Pass Road Elementary, and today we are going to meet the planets. So we will be looking at 3 different standards today, and the first standard says that we are going to obtain information and analyze how our understanding of the solar system has evolved over time. The second standard says that we're going to develop and use models of the Earth's solar system to demonstrate the size, composition, location, and order of the planets as they orbit the sun. And the final standard that we're going to focus on today says that we are going to use evidence to argue why the sun appears to be brighter than the other stars in the sky. So, our goals to go along with these standards are to first understand previous and current beliefs about the solar system. Our second goal is to differentiate between the planets and their characteristics. And our final goal is to describe why the sun appears brighter than other stars in the sky. So, our essential question that we want to keep in mind as we go today is, how has our understanding of the solar system changed over time? So we are going to start out with a little bit of a history lesson. So the first thing that we're going to look at is how astronomers thought about the solar system in the past versus how astronomers currently think about the solar system. So we're going to watch this quick video, and hopefully it'll give us a good understanding of the differences between how the solar system is seen and understood. Enjoy!
The A to Z of isms. Geocentrism. Until the 16th century, geocentrism was the prevailing theory of what the universe looked like. Geocentrism is the belief that the Earth, our home planet, is at the centre of the universe. Everything else revolves around us. This seemed obvious to ancient astronomers. After all, they observed the sun and the moon, the planets and the stars, to move across the sky as we go forward through time, just like we do today. So this must mean that the Earth is in the centre of it all, right? Wrong. The earliest geocentric models of ancient Greek philosophers / scientists / general all-rounders such as Plato and Aristotle in the 4th century BC placed a stationary Earth at the centre, with the planets and the stars moving around us on circles or spheres. The thing is, the simple geocentric model couldn't quite explain all that we see when we watch the skies. For a start, the planets change brightness, which shouldn't happen if they're always the same distance from the Earth. Second, the paths of Mars and Jupiter through the sky sometimes appear to go backwards for a time, which shouldn't happen if they're travelling around in these neat little circles. Despite this, the theory had such a hold, and astronomers were so convinced by it, that they spent hundreds of years making all sorts of modifications to try and make the general theory fit. And as needlessly complicated as it now seems to modern astronomers, this version of the universe proposed by Ptolemy in the 2nd century was almost universally accepted for hundreds of years, but not everyone was happy. As far back as the 3rd century BC, Aristarchus of Samos had suggested that the sun was in the centre of the universe. And in the years that followed Ptolemy's work, both European and Islamic scientists started to question aspects of his geocentric model. Finally, in the 16th century, Polish astronomer Copernicus published his model of the universe, which also put the sun, not the Earth, at the centre of it all. This is known as heliocentrism, and for the first time, mainstream science took note. Today we know that even heliocentrism doesn't tell the full story. While the sun may be at the centre of our solar system, it is just one of over 100 billion stars in our Milky Way galaxy, which is itself one of over 100 billion galaxies in the observable universe. Not only do we have to contend with being just one of probably countless planets out there, modern cosmology tells us that the Earth in our solar system doesn't even occupy a special place in the universe. And in fact, it turns out that there is no centre to this universe at all. Rest in peace, geocentrism.
Thanks for watching. Don't forget to subscribe and click the bell to receive notifications for new videos. See you again soon.
Mercury is one of the inner planets, meaning it's one of the ones that are closer to the sun. It is also one of the rocky planets. So when I say rocky, that's describing its surface. As we just said, it's the smallest in our solar system. Mercury, unlike us, it has 0 moons, so no moons at all. And it takes Mercury 59 Earth days to rotate. So 1 day on Mercury is like 59 days. That's almost 2 months on Earth. So imagine a school day on Mercury. Whew, you guys would not be happy. So even though it takes a long time for a day to pass, a year on Mercury is actually much, much shorter. In fact, it only takes Mercury 88 days to orbit the sun. So one Earth year on Mercury is about every 3 months. So even though the days pass by super, super slowly, the year actually passes by really, really quickly. Now, even though we would think that Mercury is the hottest planet because it's the closest to the sun, it's actually not, because it doesn't have an atmosphere to trap in the heat from the sun. So don't get that confused. Even though it's the closest to the sun, it's not the hottest. The next planet that we're going to meet is Venus. It is the hottest planet in the solar system. Venus is an inner and rocky planet. It is the second from the sun, and it's our closest neighbor. And it actually spins in opposite direction than most planets. So Venus does her own thing. 1 day on Venus is even longer than Mercury. 1 day on Venus is 243 Earth days. So again, very, very long days. Now, 1 year on Venus is about 225 days on Earth. So the year is a little bit shorter than it is on ours, but again, those days are super, super long. Venus is about the same size as Earth, and again, it's the hottest planet, and that's due to its thick atmosphere that traps in all those gases and all that heat from the sun. Venus's surface is filled with volcanoes, so again, adding to that heat. And Venus, unfortunately, has no moons. Then we have Earth, the place that we call home. Little fun fact, Earth is also the only planet with liquid. Now, some scientists are discovering that there may be ice or other forms of liquid on other planets, but as of now, it is the planet, and we can definitely say with the most liquid. So, Earth is third from the sun. It is also an inner rocky planet. And again, it's the only known world with liquid water that's actually on the surface. So astronomers and scientists, when they go to other planets, they're usually digging for water or trying to find liquid. But on Earth, we don't have to dig. We don't have to search. It's right here on the surface. Earth is the 5th largest planet in the solar system. And luckily for us, it has a protective atmosphere that shields us from harmful gases and asteroids and meteoroids and things like that. Of course, as we know, Earth has just one moon that orbits all around us each day. Next, we have Mars. Mars is really dusty and cold, and it has a pretty thin atmosphere, so not a lot of protection in that atmosphere. It is 4th from the sun. It's also an inner rocky planet. The days are about the same amount of time as they are here on Earth, so approximately 24 hours. But 1 year on Mars equals 687 days on Earth. So their years are about twice as long as us. Now, Mars actually has 2 moons, so not one, but 2 moons. And Mars is commonly known as the red planet because of the surface's red appearance that is due to rusted iron that's on the surface. Then we have Jupiter. Jupiter is twice the size of other planets, so it's known as a giant. It is 5th from the sun. It's an outer planet because it's not as close. And it's also a gas giant. Like we said, it's twice the size of the other planets. Twice as massive as all of the planets combined. So huge. Jupiter is also known for having a huge spot on it that's actually the size of Earth. but it's not just a spot. It's actually a storm that has been going on for hundreds and hundreds of years. So if you've ever seen what like the eye of a hurricane looks like on the surface of the earth, that's what it looks like on Jupiter. One day on Jupiter is actually pretty shorter than ours. It's about 10 hours, so a little less than half the time. Now, the years on Jupiter, on the other hand, a little bit longer. One Jupiter year is equal to 12 Earth years, so very, very long. The average temperature on Jupiter is about negative 234 degrees, so bring your jacket if you're going to Jupiter because it is below freezing. Jupiter also has over 75 moons, so a whole lot of moons, and it has a very faint ring system, so a set of rings around it that you can see with specialized tools. Next, we have Saturn, and as we know, Saturn is surrounded by a series of very icy, beautiful rings. It is 6 from the sun. Again, it's an outer planet and a gas giant. It is the second largest planet in our solar system. And as I said, it's known for its gorgeous, gorgeous rings. And one Earth day is about 10 hours on Saturn. But 1 year on Saturn is about 29 years on Earth. So these years on these outer planets are very, very long. And finally, Saturn has about 53 moons. Next, we have Uranus. Now, this planet is pretty unique because it rotates on a tilt. So as you can see in the picture here, it looks like it's sideways. Now, this planet is 7th from the sun, so it's pretty far away. Like the others, it's an outer planet and a gas giant. Its days on this planet is about 17 hours. 1 year is about 89 Earth years, so it's getting longer and longer. This planet is also an ice giant. It has 27 moons, 13 rings, and like we said, it rotates on its side, which I think is really, really cool. And finally, we have good old Neptune. Neptune is actually the smallest gas giant, but it's the farthest from the sun. Neptune is the windiest planet. Like the others, it's an outer planet and a gas giant. Their day is kind of similar. It's a little bit shorter than ours. A day on Neptune is about 16 hours. It has 14 moons that scientists know of. There may be more by now, but about 14 that they are sure of. It has 5 main rings, and since it is so far from the sun, it's the coldest planet. So all of these gas giants, these outer planets, they are very, very cold. Now, we are going to talk about the sun because if you recall, one of our main goals is to figure out why the sun appears to be brighter than the other stars in the sky. So we're going to read this quick article about the sun and see if we can get a little bit of insight. Our solar system includes 9 planets and the sun. The sun is a star found at the center of our solar system. It is also the largest object in our solar system. In fact, the mass of the 9 planets added together is only 0.2% of the mass in our entire solar system. The sun makes up the other 99.8%. The sun is so large that over 1 million Earths could fit inside. In order to travel around the entire sun, it would take a very long time. The distance around the sun is 2,713,406 miles. This would be like flying around the Earth 109 times. That is insane. Even though the sun is very large, it is still considered a dwarf star. Specifically, it is known as a yellow dwarf. The largest stars are called supergiants, which are huge. Our sun could fit into a supergiant 1 million times. One day, our sun will become a supergiant, but not for at least the next 5 billion years. By then, it will be 9.5 billion years old. So that's really interesting to think about how much bigger the sun is than all of the planets, but in relation to other stars, it's actually pretty small. It's considered a dwarf star. 3/4 of the sun is made of hydrogen, and most of the remaining part is helium. Basically, it's a huge ball of gas and is extremely hot. The inside of the sun can reach up to 15 million degrees Fahrenheit. I think I'm gonna stop complaining about our heat here in Mississippi. The surface is usually around 10,000 degrees Fahrenheit. Because it is so hot, its heat and light can reach the Earth, which is 92.96 million miles away, in only 8 minutes. It would take us millions of years to travel that same distance. Without the energy and sunlight that it provides to the Earth, plants could not grow, animals would not have any food, and people would not be able to survive. Because the sun is so important, it has been worshipped by many different cultures for thousands of years. In Spanish, the sun is called El Sol. Sol was the name of the ancient Roman god of the sun. That is where we get the word Sunday. Sunday was the day of the sun god in ancient Roman culture. Today, people know that the earth revolves around the sun, but in ancient times, people believed that the sun revolved around the earth. We learned about that in the video earlier. People that thought differently were punished by the church and laughed at by others. One person who thought differently was an astronomer named Nicholas Copernicus. In 1543, he said that the earth revolved around the sun. He was afraid to share his thoughts to anyone, so he waited to publish his ideas until he was very old and close to death. In the 1600s, another astronomer named Galileo published a book using Copernicus's ideas, and a scientist named Sir Isaac Newton made a special telescope. These events caused people to believe that the sun was indeed the center of our solar system. The next time you see a beautiful sunset or pretty sunrise, you might think differently. The sun is an amazing thing. So, that was a very informational article all about the sun, its size, how people worshipped it, and many other different things that are really, really cool. But again, we want to know, why does the sun appear much bigger, much brighter than all of the other stars in the sky, despite it being just a dwarf star? So let's watch this quick video and see if it can tell us. Enjoy!
Let's continue our chat from last time about stars that are not you. I mean, the stars in our universe. We've already talked about what a star is. A huge ball of hot gas that makes heat and light. Basically, they glow. But how do they glow? And why do some stars seem to glow brighter than others? Let's tackle question numero uno first. How do they glow? All stars create energy in their core through a process called nuclear fusion. Sounds super cool, right? It is. Well, super hot actually, but you get the idea. It's neat. It's also way too complicated to explain in one video, so I'll just give you a really basic overview. The temperatures and pressures inside a star are so great that nuclear fusion, the same thing that powers hydrogen bombs, is almost constantly happening at the center of a star. Most stars are made up of mostly two kinds of gases, hydrogen and helium. During nuclear fusion, hydrogen molecules, really tiny units of hydrogen, smash into each other or fuse together to create helium. The enormous amount of energy that's created as a result of this fusion then travels out towards the surface of the star as heat and light and gives the star its glow. All stars go through this process to get their glow, but they don't all shine equally, leading us to our second question. Why do some stars glow brighter than others? Stars have different brightnesses. There are two major things that astronomers look at when determining how bright a star is: its true brightness and its apparent brightness. Astronomers sometimes refer to a star's true brightness as its luminosity,
luminosity. Luminosity is a measure of how much energy or light a star shines from its surface. Think of stars like light bulbs. Light bulbs with higher wattages or more power glow brighter, right? Same thing with stars. The more luminous or powerful a star is, the brighter it glows. When measuring luminosity, astronomers are considering how bright the star is as if they were in space, standing, or I guess hovering, right in front of it. That's why they call it true brightness. It's how bright the star really is, not just how bright it might look, depending on where you are. So, how does a star's size factor in? Some stars are really, really big, and some are really, well, not small, but smaller. So if it's bigger, it must glow brighter, right? Not necessarily. Smaller stars sometimes have more power than bigger stars, just like smaller light bulbs can have more wattage than bigger light bulbs. Size also isn't necessarily important when measuring the second thing that astronomers look at when determining a star's brightness. It's apparent brightness. When we talk about apparent brightness, distance is a bigger factor than size. Since astronomers can't really go into space to see those stars up close because, they'd burn up and it would take too long to actually get to another star, they'd also measure how bright a star appears to us from a distance. This measure is called its apparent brightness. So regardless of its size or its power, how near or far a star is to Earth plays a big part in how bright it appears to us. Not convinced? Let's take a look at two stars to see if the more luminous one also appears brighter to us Earthlings. First, meet Betelgeuse. Betelgeuse is a star, one of the brightest stars in the night sky, in fact. Betelgeuse shines with around 100,000 times more luminosity, or power, than the sun, so you'll need some serious shades to look at this guy up close. But how does that compare to the sun? The sun is a star we've all spotted from Earth way more times than we've seen Betelgeuse. Since we have no problem locating it, it must be bigger than Betelgeuse, right? Nope. I mean, don't get me wrong, the sun is huge. More than 1 million Earths could fit inside it. But it's not so big when you compare it to Betelgeuse. Because Betelgeuse is gigantic, about 400 times bigger than the sun. But because Betelgeuse is located much farther away from us than the sun is, it appears less bright to us. If the sun was located that far away, you'd need a telescope to see it at all, since it doesn't have as much power as Betelgeuse. So it's not the sun's size or power that makes it seem so big and bright to us on Earth. It's because it's so close to us, just 150 million kilometers away. So Betelgeuse is bigger and more luminous, or has a higher true brightness than the sun. And you'd be able to tell that if you could look at them side by side. But the sun has a higher apparent brightness to us on Earth because it's so much closer. So let's call this brightness battle a tie. To recap, stars glow as a result of the energy created in their core by nuclear fusion. That energy travels outward to the surface of the star, where it's seen and felt as light and heat. All stars glow because of nuclear fusion, but they don't glow equally. The amount of power a star has and its distance from us both influence its brightness. On that note, I think it's time for me to do some stargazing of my own. Astronomer Sabrina's out!
All right, so we have watched our video. I think it told us the answer to why the sun appears so much brighter, despite the fact that it's actually smaller than most stars. So I hope you enjoyed meeting the planets today. I hope you learned a lot in today's lesson, and I will see you all next time. Bye.